In 1881, France launched the most expensive engineering project on Earth, a canal to split two continents apart. They had billions of francs, 20,000 workers, and the one man everyone believed could pull it off, Ferdinand de Lesseps, the engineer who'd already carved a canal through the Egyptian desert and changed global shipping forever. He was the most celebrated builder alive. Entire nations trusted his judgment. The budget was massive, the machinery was cutting edge, the political will was absolute. The ambition, honestly, was limitless. And it was all destroyed by a puddle. Not a flood, not a river, not even a swamp. A small ceramic dish, roughly the size of an ashtray, filled with clean water and placed under the leg of a hospital bed. That dish, repeated under every bed, in every ward, across the entire canal zone, became the deadliest weapon in the history of infrastructure, because the water in those dishes bred mosquitoes, and those mosquitoes carried yellow fever. And the hospitals built to save workers didn't cure anyone. They manufactured death at industrial scale. Patients walked in with broken bones and never walked out. Workers arrived for treatment and left in coffins, or didn't leave at all. 22,000 workers would die. The company would go bankrupt, and the whole project would collapse, not because of the mountain they couldn't dig through, but because of the insect they were accidentally feeding. This is the story of the Panama Canal, and the smallest failure that destroyed it. The year is 1881, and Ferdinand de Lesseps is probably the most celebrated engineer on the planet. 12 years earlier, he carved the Suez Canal through the Egyptian desert, a flat, dry 100-mile trench connecting the Mediterranean to the Red Sea. It took 10 years. It cost hundreds of millions of francs. And when it opened in 1869, it completely reshaped how the world moved goods by sea. De Lesseps became a national hero overnight. France called him Le Grand Français, the Great Frenchman. So when the idea came up of building another canal, this time through Panama, a 50-mile strip of land separating the Atlantic from the Pacific, de Lesseps stepped forward and said, essentially, "I've done this before. I can do it again." He convinced the French government and thousands of private investors to back a new venture, the Compagnie Universelle du Canal Interoceanique. The budget was staggering, the equivalent of over $287 million in 1880s money. Engineers, geologists, and an enormous labor force, most of them recruited from Jamaica, Barbados, and other Caribbean islands, were shipped to the Isthmus of Panama. The whole operation was designed to mirror what had worked at Suez, the same methods, the same confidence, the same straight-line logic. The plan was straightforward. Dig a sea-level canal, just like Suez. No locks, no dams, just a straight cut through the mountains. But here's what de Lesseps didn't account for. He'd built his reputation in a desert. Egypt was flat, dry, and almost surgically sterile. Panama was the exact opposite, a dense, wet pressure cooker of rotting vegetation, standing water, and heat that never ever let up. And hiding inside that green chaos was something no shovel, no explosive, and no amount of French engineering could fight. The jungle was dense. The rain was relentless. The Chagres River flooded without warning, wiping out weeks of excavation in a single afternoon. But none of these were the real enemy. The real enemy was invisible, a mosquito called Aedes aegypti, and it was already breeding in every puddle, every ditch, every container of still water across the canal zone. The French just didn't know it yet. And here's the thing, on paper, the French had absolutely no reason to fail. They'd assembled the largest fleet of steam-powered excavators ever deployed in one place, ladder dredgers, Decauville rail lines, bucket chain machines, all tearing into the spine of Central America at a place called the Culebra Cut, where the Continental Divide rose 64 meters above sea level. The goal was to dig straight through it, and at peak capacity, nearly 19,000 workers were on site with barges hauling spoil to the coasts and supply ships rotating in from Le Havre, Kingston, and Martinique. And yet, the project kept hemorrhaging workers, not from cave-ins, not from exhaustion, from fever, yellow fever, malaria, dysentery, and no one could figure out why. See, at the time, the dominant medical theory in Europe was something called miasma theory. The idea was simple. Diseases came from bad air, noxious vapors rising from swamps, from rotting vegetation, from stagnant water. If the air smelled dangerous, it was dangerous. Clean the air, stop the sickness. That was the logic. So the French did exactly what miasma theory told them to do. They cleared vegetation near the hospitals. They planted gardens to purify the air. They built drainage ditches and kept the wards spotless, but they never once considered the mosquito. Now here's the part that turns this story from a tragedy into something almost grotesque. The Aedes aegypti, the species that carries yellow fever, doesn't need a swamp to breed. It doesn't need a river or a lake. It needs standing water, clean, still, undisturbed water, a puddle, a tin can, a flower vase, or a small ceramic pot at the foot of a hospital bed. And the French hospitals in the Canal Zone, including the main facility at Ancon Hill, had a pest problem: ants. They crawled over patients, got into bandages, contaminated food. So the hospital staff came up with a simple, clever fix. They placed the legs of every bed into small dishes filled with water, creating little moats around each bedpost. Problem solved. No more ants. It was also the single deadliest decision of the entire project, because every one of those water dishes became a nursery for Aedes aegypti larvae. The mosquitoes hatched inches from the patients. They bit the sick. They picked up the virus. Then they drifted to the next bed and bit someone else. A laborer who came in with a broken arm never left the ward. A man recovering from heat exhaustion, his skin turned yellow, his body shut down, and he was buried before anyone could notify his family. The hospitals weren't treating the disease. They were distributing it, and the doctors had no idea. They recorded the deaths carefully, the fevers, the jaundice, the organ failure. But when they looked for the cause, they looked at the air, they looked at the soil, they looked at the food and the water supply. They never looked down at the 4 ceramic dishes sitting quietly under every bed, teeming with larvae. By 1884, the entire operation was in freefall. During the worst yellow fever seasons, whole shifts of workers would be dead within weeks of arriving. New laborers stepped off the boat in Cologne, reported to their work site, and were carried to the hospital before their first paycheck cleared. Some never even made it to the dig. The numbers were brutal. In certain months, 1 out of every 10 workers died, and the ones who died fastest were the fresh recruits from the Caribbean, young, strong men who'd never been exposed to yellow fever. The disease moved through them with devastating speed. Think about what that cycle actually looked like. A worker gets sick. He goes to the hospital. Inside the hospital, the mosquitoes are breeding under every bed. They infect him. He infects more mosquitoes. Those mosquitoes infect the next patient. The hospital wasn't containing the epidemic. It was amplifying it. Now picture this: a 23-year-old carpenter from Kingston. He sailed 5 days to reach Cologne. He's strong, he's healthy, and he's planning to send his wages back to his family. On his 3rd week, a beam falls on his leg. They carry him to the hospital at Ancon Hill, the best facility in the Canal Zone. Clean wards, French doctors, running water. Under his bed, 4 ceramic dishes filled with water. Keep the ants away. Within 12 days, his skin turns yellow. He stops eating. By the 15th day, he's gone, not from the injury, but from the very hospital that was supposed to save him. His name doesn't appear in the company records. Meanwhile, the engineering itself was falling apart. The Culebra Cut was a geological nightmare. The French excavated roughly 14 million cubic meters of earth over 8 years. But the soil was unstable. Massive landslides, sometimes triggered by nothing more than heavy rain, sent thousands of tons of rock and clay sliding back into the trench, erasing months of progress in a single afternoon. The Chagres River made it worse. Every rainy season it swelled into a violent torrent, flooding the canal trench and drowning equipment. Engineers proposed dams and diversions, but none of the designs were ever built. Every wet season was a reset button, and beneath all of it, the money was disappearing faster than the earth. De Lesseps had sold this dream to school teachers, shopkeepers, and retirees, over 800,000 ordinary French citizens who bought bonds because they trusted the hero of Suez. But the original budget of 600 million francs had ballooned. By 1888, the company had burned through over 1.4 billion. De Lesseps tried one last desperate gamble, a lottery bond to raise emergency funds. The French Parliament blocked it after allegations of widespread bribery. In February 1889, the Compagnie Universelle du Canal Interoceanique declared bankruptcy. It was the largest financial collapse in French history. 800,000 investors lost their savings. Ferdinand de Lesseps was convicted of fraud and conspiracy. He was sentenced to 5 years in prison. Though he never served a day, his mind was already failing. He spent his last years in a fog of dementia, reportedly unaware that his canal had been abandoned. 22,000 workers were dead. The canal was a flooded ditch, and the mosquito, it just kept breeding. The French failure didn't just kill a project, it killed an entire era of imperial engineering confidence. For the next decade, the canal zone sat abandoned. Rusting steam shovels sank into the mud. Rail lines warped in the tropical heat. The jungle, patient, indifferent, and completely unconcerned with French ambition, reclaimed everything. Vines crawled over the Decaying tracks. Trees pushed through the floors of abandoned barracks. Crocodiles returned to the flooded trenches. The hospitals at Ancon Hill stood empty, their wards still furnished with iron beds, the ceramic pots still sitting under the legs, dry now, cracked, but unmoved. Nobody had thought to remove them. Back in France, the aftermath was political dynamite. The Panama scandal, as it came to be known, exposed a web of corruption that reached deep into the halls of government. Ministers, senators, newspaper editors, all bribed to keep investors buying bonds long after the project was clearly doomed. Over 100 officials were implicated, careers destroyed, reputations shattered overnight. The scandal broke public trust in the Third Republic so badly that the word Panama itself became French slang for a swindle. But the most devastating consequence wasn't political. It was biological. 22,000 dead, most of them unnamed Caribbean laborers. Men from Jamaica, Martinique, Barbados, buried in mass graves along the canal route. No monuments, no memorials. Just mounds of earth that the jungle swallowed within a single rainy season. And here's the part that's hard to sit with. Their deaths weren't accidents. They weren't the inevitable cost of engineering. They were the cost of a wrong theory. Miasma theory told the French that clean air meant safety, so they opened every hospital window wide to let the breeze flow through, and every open window was an invitation to the mosquito. They planted lush gardens around the hospital grounds to freshen the air. Those gardens held potted plants. Those plants sat in clay saucers filled with water, more breeding sites. They placed cut flowers in vases beside patient beds, a small gesture of comfort. Each vase was another nursery for Aedes aegypti. Every humanitarian instinct the French followed, the flowers, the fresh air, the clean moats under the bed legs, was weaponized by the biology they didn't understand. The tragedy wasn't negligence. It was diligence applied in the wrong direction. They were meticulous, organized, and disciplined, and every ounce of that discipline made the epidemic worse. When the United States took over the canal zone in 1904, the first person they sent wasn't an engineer. It was a doctor. Colonel William Crawford Gorgas had already made his name in Havana, where he led the campaign that wiped out yellow fever from Cuba. And he'd done it using one radical idea that the French never had access to. The mosquito was the vector, not the air, not the soil, not the patient's diet. A 2-millimeter insect with a roughly 12-day life cycle. But here's something most people don't know. A Cuban doctor named Carlos Finlay had actually published the mosquito transmission theory back in 1881, the exact same year the French broke ground in Panama. His paper was ignored, ridiculed, filed away in a drawer. The science that could have saved 22,000 lives existed from day one. Nobody listened. Gorgas, though. Gorgas listened. He arrived in Panama and immediately started dismantling everything the French had built around their hospitals. He ripped out the flower gardens, drained the plant saucers, emptied the bedleg water pots, screened every window. He sent fumigation teams into every building in the canal zone, house by house, room by room. He ordered all standing water eliminated: puddles, ditches, rain barrels, old tires, discarded tin cans. Anything that could hold still water for more than a few days was either destroyed or treated with oil. The resistance was fierce. The canal's chief engineer initially considered Gorgas a nuisance, a medical bureaucrat slowing down the real work. But Gorgas had the data, and within roughly 18 months, yellow fever was gone from the canal zone entirely. Malaria rates dropped by about 80%. The canal was completed in 1914. The Americans didn't succeed because they had better shovels, or more dynamite, or a smarter design, though they had all three. They succeeded because they understood something the French never did. In Panama, the hardest material to move wasn't rock, it was a disease vector. And this is the part that should make you uncomfortable. The French weren't fools. They were doing exactly what you or I would have done with the medical knowledge available in 1882. They weren't wrong because they were careless. They were wrong because they followed the best science of their era, and the best science was incomplete. Confidence without comprehension turned out to be the most expensive failure mode in engineering. The constraint that kills a project is almost never the one on the blueprint. It's the one nobody thought to model. The invisible variable. The thing everyone assumes is background noise. The French planned for rock, for rain, for rivers. They never planned for a puddle. Ferdinand de Lesseps died in 1894, 5 years after his company collapsed. He never saw his canal built. The man who conquered the desert at Suez was undone by a jungle he thought he could master the same way. But the real lesson of Panama isn't about de Lesseps. It's not even about the canal. It's about the bed. Picture it for a second. A hospital ward in the tropical heat. Rows of iron beds, white sheets soaked through with sweat. Outside, the sound of steam shovels grinding into the culebra cut. Inside, a patient lies still, his skin yellow with jaundice, his body fighting a war it doesn't understand. Under his bed, 4 small ceramic dishes, each filled with a few centimeters of clean water, changed regularly, part of a system designed to keep the ward sanitary. And in that water, dozens of larvae, curling, pulsing, becoming mosquitoes, becoming carriers, becoming the next wave. The entire French canal enterprise, the shovels, the dynamite, the railroads, the billions of francs, the political ambitions of an empire, all of it was undone by something that could fit in a teacup. That's the thing about systems. The most dangerous failures don't come from the biggest components. They come from the smallest ones, the ones nobody examines because they seem too trivial to matter. The French didn't lose to Panama. They didn't lose to the mountain, or the river, or the jungle. They lost to a ceramic dish the size of an ashtray, because the hardest material to move in human history was never rock. It was the thing breeding in the puddle beneath the bed where the dying man slept. If the hidden mechanics behind history's greatest failures fascinate you, subscribe to Logistics of Power. There are many more systems that broke the world in ways nobody expected.